So we're going to go through these prerequisite skills, which it's kind of weird to call it that because some of it is sort of new. We'll start off with number one. So number one, guys, I will get in the swing of this whole video thing soon enough so that it seems a little bit better, but hopefully this will work out for you guys. Okay, so 1A is we have to put in x equals 2 into y equals 3x plus 4. Okay, so I didn't give you guys a lesson on this, so here it is. We're going to copy down the line with the equation. We're going to, instead of putting an x, I like to just put an open set of brackets. Okay, so I've copied down everything except the x. I put an open set of brackets, and now we just put the whole x equals 2 thing into those brackets and just do the math. So you get y equals 6 plus 4, which is 10. Okay? So for the next one, I think this is where we started to run into difficulties yesterday with order of operations. So it's y equals negative 2, x squared plus 3x plus 1. Guys, even though I'm recording, if you have questions, just don't hesitate. So we're going to do the exact same thing again. We're going to replace all the x's with brackets. Alright, so notice I left the squared on where the x was. It's just on a bracket now. Okay, so now we're going to put the x equals 2 in there. And then you're going to go y equals. Now, we have to do brackets first with BEDMAS, but there's nothing to do in the brackets, so we move on to the next thing, exponents. So the exponent there only applies to the 2 in the bracket. So it's going to be 2 squared is 4. So we got negative 2 times 4 plus 6 plus 1. So you're going to get negative 8 plus 6 plus 1. And that is going to be negative 1. Can you guys see this okay? I can probably zoom in a little bit more here. Maybe not. Alright, so next thing, same idea. Okay, so we're going to substitute 3 into there, so you're going to get y equals. Now, if you want to write it in and just put the 3 in the brackets, or you can do what we did before, put the brackets, then put the 3 in, that works too. So you should get negative 7 for this one. Negative 9 plus 2, negative 7. Okay, next one. Okay, so we got y equals. Okay, so replace the x with brackets. The x's are just placeholders. Put the 4 in, and that's going to give you 16 minus 8 plus 2. So guys, 10? Everyone cool with 10 for that? Yeah? Not recording. Okay, there we go. So number 3. We had to make a table of values. Okay, guys. I'm a little bit about teaching you how to be efficient when you do these things, okay? So if you have a half-decent calculator, like this one, what you can do is just put in the numbers the way we talked about before, where you make placeholders, basically. So what I'm going to do is I'm going to go and just put the equation in. Now, can you guys see that? Not really. Okay, so I've put the equation in bracket squared plus 3 bracket minus 1. And then what you could do from there, now you don't necessarily need to put the brackets in, but it's going to help you when you put the negatives in there. So if you find the button, the proper button to put in numbers here, we want to put in -2. And then I'm going to put in -2 here. Okay, so there's the whole thing. Press equals. We get -3 for that. Okay, now I want you guys to be able to put this in your calculator, but I also want you to be able to figure it out by hand. Okay, but once you know how to do it by hand, there's nothing wrong with taking a shortcut to fill in a table, because maybe we're not learning how to do a table, we're learning how to graph something or what something looks like, and then we'll need shortcuts to do it efficiently. So we get -3, then all I'm going to do is go back and put it, just overwrite the 2's and make it a -1 now. And I get -3 again. And then I'm not going to put 0 in, because that just seems like a waste of time. What we're going to do now is just look at this and go, okay, 0 squared 0, plus 3 times 0 is 0, minus 1. So we're going to get an answer of -1 there. Now we can go back and just take out the negative signs. Okay, press equals, you get 3. Go back, put in 2. And we get 9. All right. Questions, concerns, anything so far? All right. So, number 4, use technology and graph this. Okay, I am just going to do a quick sketch for you guys here, because it wasn't the nicest graph anyway. It's supposed to be a parabola. So you had the point -2, -3. You had the point -1, -3. And then you had 0 and -1. 1 and 3. 2 and 9. Okay, you guys are probably remembering from last year looking for a parabola, but you're like, there's like a straight line here. Well, they didn't give you the vertex. The vertex, this is kind of review, but we'll learn it again. The vertex is going to be on the axis of symmetry. So if you wanted to put it in, it would be right there. And then what you can do from there, if you wanted to, you didn't have to do this for this question, I'm just doing it because we're at this point now. We could mirror all of these points over this dotted line, that's the axis of symmetry. So then we'd have one here, and then that would look like more like a parabola that you're used to from last year. All right? Any questions for that? That's really number 4 here, I guess, is the graph. All right, moving on to number 5. I am going to actually do 5 right on the paper. Okay, so you're going to get, you got to square the x value, times it by 2, and then add 4 times the x value. So let's just do one kind of sample calculation, and then we'll just kind of fill in the rest fast. So we got y equals 2, -3 squared, plus 4 times -3. Okay, -3 squared is, anybody? Careful, not 6. Yeah, 9, yeah. So 2 negatives multiplied, so you're multiplying -3 by -3, and you get positive 9. So 9 times 2 is 18, plus that will be -12. So we got 18 plus -12, and you get an answer of 6. When you do that with -2, you're going to get 2 times 4 is 8, minus 8 is 0. -1 will give you 2 minus 4 is -2. 0 gives you 0. 1 gives you 6. 2 gives you 16. And what's the last one? 30 is good. All right. So when you do first differences, you're going to want to, you're always taking away the number before it. We talked about this a little bit yesterday. The first difference is just what your numbers are going up by. So in this case, we're going 0 take away 6 is -6. -2 take away 0 is -2. 0 take away -2 is going to be +2. 6 take away 0, 6. 16 take away 6, 10. And the next one's 14. What you can see now, and it was kind of confusing what I just said. I said, well, the first differences are just what it's going up by. So what you can start to see here is, well, it wasn't, these numbers were going up by different amounts, but with these numbers we can see a pattern here. These numbers are actually going up by 4 every time. If you look at these, you go, okay, -6 to -2, that's going up by 4. -2 to +2, that's going up by 4. And then here's where you really see it, 2 to 6, that's going up by 4. 6 to 10 goes up by 4, and 10 to 14 goes up by 4. So when you actually do what you're supposed to do with the subtracting, -2 take away -6. Well, that just gives you 4, like we just said. And the rest of them are also all 4. So if you can look at the numbers, either the y values or the first differences, and say, hey, they're going up by the same amount every time, you automatically know the answer. And you can just write that in. And I don't mind that if you don't show all your work every time for that, if it's that obvious. If it's not obvious, then yeah, show your work and make sure you get all the numbers. But there we go. Okay, so what you should notice here, second difference is all the same because it's a quadratic. So anytime you have the highest power on x being a 2, your second differences should all be the same. Okay. Next one. Number 6 is a really weird question. It wants you to graph a point, a single point, not even a parabola. So it says that find the image of the point 3, 4 after each of the following transformations. So that's the point 3, 4, so I'm going to label that P for point. Okay? For part A, it wants us to move it 3 units to the left. Okay, move 3 units left. 1, 2, 3. That's point A. Then we're going to take that point. I'm going to assume they want us to move the point we just moved. So we're going to move it 6 units down. So that's 4, 5, 6 right there. That's point B. Then they want us to reflect that in the x-axis, so we're going to reflect it over and put it here. Morgan, what's up?
Instead of that, I just used like the first.
Record again. Okay, so number 8, guys. It gave us the original measurements of this cardboard, and they've already cut it out. They just want to know the surface area of the box. Now, what are we assuming here? Like, they tell us there's no top on it, we're not going to go all next level and go, well, do they want the surface area of the outside and the inside? I mean, that might be a valid thing, but if they wanted that, we'd just double it at the end of the day anyway. So what we're going to do here is say to ourselves, well, these are all squares. We know the measurements now. They're all 10 by 10. So that base would be 10 by 10 is 100, and there's 5 squares. So we're just going to go 10 times 10 equals 100. There's 5 of them, so it's 5 times 100 equals 500. What are the units here? Centimeters, so it's going to be centimeters squared. Good. Okay, now they want volume. So the volume is just the amount of, like, say, water that this thing could hold. Not that you want to put water in a cardboard box, but do you guys remember the formula for volume? So yeah, one is length times width times height. That one works. The way I learned it back in the day was the area of the face times the height. So if we take that area at the bottom, which is 100, and we times it by the height, that will also give us the volume. But it's the same thing. So you could just do the V is equal to length times width times height. That works for any rectangular prism. Because this is a cube, we could have also just gone side length cubed, and that would have worked as well. Because that's what we're doing actually, is 10 times 10 times 10. And you get 1,000, and the difference now is this is going to be centimeters cubed.